and utterly failed in my last water cooling video because I accidentally, and I still don't know how I did it, I could have swore I edited it, the entire segment about pumps and reservoirs. So anyway, we're gonna go ahead and talk about it again. Although, first time for you guys, second time for me. Doesn't get any easier, guys, I swear. Have you been putting off water cooling your computer because you're afraid that you're a klutz and you're just gonna screw it up? Well, that's okay, because EK Waterblocks is launching its brand new line of Predator water cooling loops that feature the exact same components that you would find in standalone custom-built loops already put together for you. Okay, so water pumps for your computer are no different than any other water pump on any system on the face of the planet. It's nothing more than a device to move a body of water through a system. Doesn't matter if it's a car or an aquarium or a pool, they all work pretty much identical, where the impeller is gonna move and water is gonna flow. That's all there is to it. Now, water cooling pumps over the years have been pretty much nothing more than adapted industrial solutions to work in our PCs. Now, companies like Lang have made the famous D5 and DDC pumps, and at the risk of sounding like a fanboy, those are the only two pumps I personally recommend, period. They're the only pumps that I use in my systems as long as your budget can afford it, because they're not really very cheap, but they are quite literally the best that you can get. Now, you might be sitting there at your screen going, Jay, you're so full of shit. You just said you only use Lang D5s and DDCs, but you've used SwiftTech and you've used AlphaCool and you've used EK Waterblocks. Well, you just hold your horses there, because Lang is the ODM for those brands, where those brands buy the pumps from Lang and they put their sticker on it, and then they come up with their own pump top solutions. That way they work in your PCs, because the pump itself is still no different than, I need to stop my chair from rocking back here. I'm gonna like fall back in the middle of this video. There's still nothing more than industrial pumps that are being used in your PC. So it was these PC manufacturers like XSPC and EK Waterblocks and SwiftTech, AlphaCool, that have all come up with their own pump tops to make them work in your PCs. Now, a pump top is nothing more than something that attaches to the pump so that you can attach fittings to it and mount the pump. That's all a pump top is. Now, usually, this is an AlphaCool D5 pump top here with multiple fittings on here for a couple inlets, a couple outlets, depending on how you're going to mount it in your system. This is a very common one that you're going to find. It's kind of a plastic, plain square. This is made out of acetal, which is a type of plastic. It's very durable, very lightweight, and easy to manufacture. So that's why you find a lot of these acetal materials. You're going to find other types of materials, though, just like how EK Waterblock does use plexi on some of their CPU tops. You're going to find materials like that are used. Just like on this water block here we've got for this 980 Ti, this is a plexi top. So you will find pump tops in both acetal, palm, and plexi. Now let's go ahead and start with the D5 pump, because that's my personal favorite. The D5 pump moves a lot of fluid, and I mean a lot. And there's two specs when it comes to shopping for a water pump that you need to understand. The first spec being liters per hour. Now that's pretty self-explanatory. It means at full speed, full operating speed for that pump, it can move X amount of liters in 1 hour time frame. Now, more liters per hour sounds like a very good thing, but just like fans, airflow and head pressure in the case of pumps works just like static pressure in the case of fans, where having more flow does not equate to better pressure. So if you have a lot of resistance in your loop and you don't have a pump that's good, a nice powerful head pressure, then you're going to have a lot of drop off the more resistance you introduce into your system. Now, over here we have Skunkworks, and we've got two loops going on there. And the reason why I'm mentioning head pressure is because there's something you need to understand with that, where even though the D5 is a high flowing pump, it is not the best pump when it comes to overcoming a lot of resistance. Now, radiators themselves are not inherently very resistant. In fact, the amount of rows that are in a radiator usually equate to a very similar amount of volume that you would find inside the inner diameter of your tube, especially if you have like hard piping like I have. So radiators, for the most part, don't add a lot of resistance. What adds resistance is like we just looked at. You've got your block here. As you can see here, you've got an inlet and an outlet, and it's got to make a very sharp 90-degree turn, go through a lot of resistance in here with different fins and channeling to touch certain parts of the die, and then it's got to make a 90-degree outlet. So it's got a lot of turns it has to make right there. Same thing happens here with the GPU block. It's got to come in, make a very sharp turn through a very small opening. It's got to come here through all these fins inside the die cooler here, right on top of the GPU die, and then it's got to make another 90, and then it's got to come here and make another 90 out. Every time your fittings go into a radiator, it makes a 90 into the radiator, another 90 and a 180 at the other side of the radiator, and another sharp 90 coming out. So what adds the resistance is these blocks and these sharp 90-degree bends in the fittings and the different parts that add this resistance. Now, most of the time, fittings are going to be channeled in such a way that they're smooth, because if they were just like 90 degrees, literally like this, then that adds a ton of resistance for the water flow. Now, as I started to mention a second ago, I have two loops going on inside Skunkworks. I've got a CPU loop, which is one radiator at the top, one CPU block, and then the reservoir and pump combo, and then the hard piping for the CPU block. The CPU loop I can run at the lowest setting and have no difference in temperature whatsoever because there's plenty of water flow. But the other loop, which is an identical pump, reservoir mounting unit for it, and identical reservoir, is running two radiators, a 560 millimeter radiator plus a 280 millimeter radiator, plus a lot of 90-degree bends down there underneath here where the side rad is. And then we've got three GPU blocks that are all making very sharp bends. I've actually got to run that pump near full speed, and it moves water slower than the CPU pump does at the lowest speed. So as you can see, the D5, although a lot of water flow, does not have the greatest amount of head pressure. You guys can correct me, but I do believe it's about 13 feet of head pressure, which means it could move water 13 feet up before gravity overcomes the pump, and then the pump can't move the fluid any farther. Now the DDC pump is much smaller. It's much more compact, but it also spins at a lot higher RPM, and because it's a smaller impeller, the higher RPM does not necessarily equate to more liters per hour, but it does equate to very good head pressure. So people have used DDC pumps and even used pump tops that allow you to hook two DDC pumps into a single loop, have overcome systems much more restrictive than mine and have no problems doing it whatsoever. But the downside to a DDC is that they get very, very hot. So that's why you see that this unit I have put together here, which is a reservoir combo with a DDC top from Bits Power and an EK heatsink on here, the heatsink is needed to keep things nice and cool, because that's one of the major differences between a D5 and a DDC, where a D5 is actually being cooled by the fluid running through it. The heat is transferred to the impeller, and then the coolant that's moving through it takes that heat and travels, takes it away into the radiator. So it's one of the downsides with the D5 is it can add heat into your loop, but as long as you have plenty of cooling, it won't matter. The DDC is going to get very toasty and relies on heatsink and air cooling to keep it nice and cool. Now, pretty much all water blocks on the market today come with things that you would find specific to PC, like PWM or pulse width modulation, where the CPU load is going to control the speed of the pump. RPM sensing wire so that you can hook it up to your CPU fan header and not have to worry about your BIOS thinking there's no fan hooked up and then giving you a warning at startup thinking that there's no fan and that your computer is going to cook itself to death. So you don't have to disable that setting, because at the same time you would want to know if your pump isn't working. And if you hook the RPM wire up to your CPU header and the pump stops spinning for some reason because it goes bad, then the CPU can warn you and you know something went wrong, rather than just disabling it and blindly having to wonder why your CPU shut down or your computer shut down because the computer overheated. Now obviously both of these pumps have reservoir combo units available on the market. Now they're not cheap. In fact, the price of the pump with the combo unit and everything can run you over $200, $250. It's not cheap whatsoever, but it's certainly a nice option if space is, very important. Now, as you can see, Skunkworks has two of them going on in there for the D5. Those are EK options. And then over here, I have a Bits Power option for the DDC, which is running a Bits Power reservoir with the Bits Power reservoir top that mounts onto, this is actually EK heatsink that has the pump in there. So you screw everything together through these bolts on the bottom, and this is what you get, a single unit that you can mount horizontally or vertically into your system. It doesn't take as many fittings, and it's much more compact and just looks really, really cool. Now, speaking of reservoirs, cylindrical reservoirs are very, very common. They look cool, they're easy to place. You can run them both vertically or horizontally as long as they have multiple fitting options here, like you can see from this EK Res X3. If you can put it on its side, if you have fittings down on the bottom, as long as the fittings are underneath the water level, then you can run it horizontally and do some cool stuff. But reservoirs are something that we didn't always have back in the past. So that's why in the previous video I called it optional, Because what we used to do was cut the tube at the top, put a T-fitting in there, run another piece of tubing off of that, put a brass plug at the end of it, and when we wanted to fill our system or drain our system, we'd remove the plug and use it's not really a syringe, it's like a fluid syringe where we could stick it in the tube and then slowly pump up our systems using that syringe to fill it full of fluid. It took a long time. It didn't have a lot of place for air to go so that you could bleed your system, which is what makes these reservoirs really, really nice, because you get tons of fluid in here. It makes filling and priming your system extremely easy because of the fact that when you turn on the pump, it's got a huge supply of fluid to pull into the system and push up into your tubing and into your reservoir or into your radiators and your blocks. And then once it empties, you stop it, fill it back up, and do it again. You guys have seen me do that in videos. It makes it a lot easier. The bigger the res, the easier it is. The reservoir has nothing to do with your cooling capacity whatsoever. You could have an entire gallon of fluid, and it's not going to run any cooler than if you had no extra fluid than what the capacity of your components can hold, because the fluid will just continue to heat up over time until it gets to the maximum operating temperature of your system. So don't think that reservoirs and big reservoirs are going to give you any better cooling capacity, because it's not. Period. End of discussion. It won't happen. But it does make it easier to fill and drain, because if you had this sitting in here and you didn't have any tubing coming in the top like I do on one of my loops on Skunkworks, you can just undo this entire cap and you have this giant opening here to put a funnel in or put another tube in and use that to pour your fluid in there. And you're not spilling everywhere. You've got lots and lots of room to work with. So that's what makes this really nice. Now, sometimes you might need to use a reservoir in a very small system because you might have to use like a 5 1/4 bay type of reservoir. I'm not a fan of 5 1/4 bay reservoirs, especially the single slot ones, because they tend to be a lot harder to fill and bleed your system and fill your system, because there's only like an inch worth of actual fluid level in there, and that can drain really fast into your pump. So you find yourself constantly flipping on the pump and it drains, and then turn it off and fill it. And it just becomes tedious to fill your system. But it's an option if it's the only option you have in a smaller system where a bay reservoir is the only thing that you can get to fit in there. But ultimately, my recommendation would be something like this if you can fit it and your budget can afford it. Like I said, these aren't cheap. So there you go, guys, my video that I unfortunately screwed up on, but maybe it was a good thing, because I got to now talk more about pumps and reservoirs than I would have in the other video, where we got to go deeper. So it might make sense to pick each one of these and even do like another 15-minute video about GPU blocks, specifically about, you know, how the different designs work and what materials, and maybe, I don't know, just, I love talking about this stuff. Water cooling is fun to me. And if it's fun to you, then make sure you share this video with someone that you think it will help. Hope you guys have enjoyed today's video. Hope it's helped you. That's the ultimate goal between these beginners buyer guide videos, where it hurts and it sucks to buy something and you're excited about it, but then you got the wrong thing because you simply didn't understand, and then it costs you money and return shipping and time, and you just get upset before you even get started, and then that can lead to disaster. So the whole point of these videos is not about views, it's not about subscribers, it's simply about helping you guys do what it is, or help you get to know what it is you need to know to do it right the first time, because then you can enjoy it. I enjoy this stuff. I've enjoyed it for years, and I will enjoy it for years to come, and I want you guys to enjoy it too. So with that said, I'm gonna get the heck on out of here. I'm gonna go play some Forza 6. I love Forza 6. I love cars, if you guys couldn't tell. You guys have seen my Instagram and my Twitter. It's always me showing pictures and talking about my my old Nissan 350Z that's old and rattly, and damn it, I love that car, and it's mine, and it's paid for. That in itself makes it valuable to me. All right, I'm gonna get out of here, guys. As always, thanks for watching.